So, the objective of this experiment is to validate the accuracy of Hooke's law. The apparatus for this experiment is helical steel spring with a supporting stand and scale, set of slotted weights with hanger, and laboratory balance.
Simple harmonic motion or SHM occurs when a body moves back and forth under the influence of a restoring force. This restoring force denoted as F, acts in the opposite direction of displacement x and is directly proportional to it. The relationship is expressed as F equal to negative kx. Here, k is the proportionality constant, and the negative sign indicates that the force always acts toward the equilibrium position, opposing the displacement. When a mass is subject to this restoring force, it oscillates back and forth. The time taken for one complete oscillation is called the period, t, and the formula for the period is t equal to 2 pi square root m over k. The frequency of oscillation denoted as f is the reciprocal of the period given by f equal to 1 over t. The maximum displacement from the equilibrium position is referred to as the amplitude of oscillation. Importantly, in simple harmonic motion, the period and the frequency are independent of amplitude. Hooke's law provides further insight into the restoring force. When an elastic spring is stretched by a force, it's extended by an amount, and the relationship is expressed as F equal to negative kx. This means that the spring pulls back with a force proportionally to the displacement. As shown in figure 1, the force required to stretch the spring doubles if the displacement doubles. The spring will continue stretching until the restoring force equal to applied force, achieving equilibrium.
Procedure. First, measure and record the mass of the hanger and the mass of the spring. Secondly, adjust the scale so that the pointer on the hanger is near the top when the hanger is empty. Record its position as X node and prepare a table for the data. Thirdly, add a 50-gram load to the hanger. Record the scale reading for the extension X. Continue adding more loads in suitable increments. They don't need to be the same. To get 8 data points before the scale reaches the bottom. Record all measurements. Caution: do not stretch the spring too much, as it may become permanently deformed. Lastly, reverse the process by removing the same loads from the spring as in step 3. Then, record the scale reading for each load. Conclusion. Hooke's law is a fundamental principle in physics that describes the relationship between the force applied to an elastic material and its resulting extension or compression. Mass, measured in kilograms, represents the amount of matter in an object. Every object experiences a gravitational force, which gives it weight. According to Hooke's law, when a weight is applied to a vertically suspended spring, the spring extends. The extension is directly proportional to the applied force when pulling, and the spring compresses proportionally when a compressive force is applied. The restoring force always acts in the opposite direction of the applied force. In this experiment, 3 different masses were used in 3 trials, and the data was recorded for graphical analysis. The resulting graph shows a linear relationship between mass and extension, with the slope representing the spring constant.